zeros of polynomial functions. So our objective for this video, we want to use factoring to find the zeros of polynomial functions. Okay, so what do we know? Well, we know what a polynomial function is. A function of the following form. F of x is equal to, and we have a coefficient times a power of x plus a coefficient times the power of x, etc., finally plus a constant. And when our powers of x's are in numerical order from greatest to least, we say that is in standard form. We know what the zeros of a function are. They are the value or the values of x for which f of x is equal to 0. Those are the zeros of a function. They're also called roots. They're also called solutions. It kind of depends on the context, but they're all the same thing. And each zero is an x-intercept of the graph of the polynomial function. If f of x is 0, we can replace f of x with y. When y is 0, we are on the x-axis. That's why these zeros are x-intercepts. Finally, we know what factoring is. We've done a lot of factoring in our past. Factoring is finding what to multiply to get a polynomial. Okay, so in other words, we're also writing a polynomial as a product of terms, perhaps, as a product of factors. So what are our factoring techniques? Well, here are a few of them. Greatest common factor, grouping, factoring a trinomial, a difference of squares, etc. And we use factoring along with the zero product property as a method to find a function's zeros. Okay, let's take a look at this. Well, let's take a look at their graphs using our graphing device. Okay, just give me a second here to get my act together. Find all zeros of f of x is equal to x cubed plus 3x squared minus x minus 3. We want to note that our powers of our x terms are in numerical order from greatest to least. So this polynomial is in standard form, and it is a third degree polynomial. We want to find the zeros. Okay, so we want to say, all right, how do we use our factoring? Our methods of factoring is one way. We're doing this algebraically to find the zeros, to find when this function is equal to 0. Well, again, we'll go back. Let me slide just a touch here, and we'll note we've got some methods we've learned in the past. This one is set up to factor by grouping. So I'm going to look here, and I'm going to say I'm going to pull an x squared term out of here, and I'm left with an x plus a 3. Okay, x squared times x is x cubed. X squared times positive 3 is positive 3x squared. And I'm going to pull a negative 1 out of this, and I'm left with the same factor, x plus 3. Okay, so then I went into this piece here, and I factored out a negative 1. And factor by grouping is finding a common factor in two groups. Here's my common factor. Okay, x plus 3 is a factor of this piece. X plus 3 is a factor of that piece. So I can rewrite this as x plus 3, okay, times x squared minus 1. Okay, so this here is factor, just to remind you, factor by grouping. Okay, so now we're here. Oops, and I forgot. This has to equal 0. Let's not forget that equals 0 piece. That's what's important. Now we can use our zero product property. The zero product property right here. If things are multiplied together and their product is 0, then either this one must be 0 or this one must be 0. Okay, the only way you get 0 as a product is if one or both are 0. So this tells us that x plus 3 is equal to 0 or x squared minus 1 is equal to 0. Okay, and we can solve these two. Subtract 3 from both sides, and this tells us that negative 3, when x equals negative 3, that's a 0. Negative 3 into here gives me a 0. Doesn't matter what this is. 0 times whatever is 0. And over here, if I add 1 to both sides, I get x squared is equal to 1. And of course, I can then square root both sides, and x is equal to positive or negative 1. Don't forget it's positive or negative. Okay? So I have 3 zeros. And I'll write them in numerical order. The zeros are negative 3, negative 1, and positive 1 are my 3 zeros. Let's take a look at that and see those x-intercepts in the graph using our graphing device. Okay, so I'm going to go into here, y equals, and my function was x cubed. So x cubed plus 3x squared minus x minus 3. And I'll press graph and I'll get my standard form and take a look at it. Okay, so there they are. You can see my 3 x-intercepts. One is here, going from left to right. One is here and one is here. We can check what those are by using our calc button. I want to calculate the zeros. Okay, and I can go over here and it says, okay, let's take a look at the first one. Let's see here. I think I made a mistake. Let's go back to that calc button again. Calculate the zeros. I forgot to go down to here. And it says, looking for the first one, give me the left bound. So then the T84, I want it to be between here. Look between here and here. So we're taking a look at this 0 between, we bounded it between the left and right here, and then take a guess. And there's my negative 3. And I can do the same thing, second calc, the 0. And I can say, okay, what's this one over here? So there's the left bound, and let's go down to the bottom below it. There's the right bound. What's the 0 in between these two bounds? Take a guess. Well, that's negative 1. And then the same thing can be over here. Calculate the 0, give it a left bound. Well, I'm going to be between here. That's to the left of this x-intercept. Let's go to the right of that x-intercept, so between these two lines, and take a guess, and there's the positive 1 right there. So there's our graphing calculator check. All right, let's do another example. Give me just a moment to switch paper. This one's going to have us do a couple different factoring techniques, just to remind you about some factoring. Okay, find all zeros of f of x equals x to the 4th minus 4x squared. Well, it's in standard form, so we're good there. So we want to know, okay, we have x to the 4th minus 4x squared. When does that equal 0? That's our question. Well, first I notice there's a common factor. Okay, the common factor is x squared. So I'll factor out an x squared, and I have x squared minus 4 equals 0. So this is factoring the greatest common factor, our greatest common factor of x squared. And then this here is a difference of squares. If you want to continue to factor it, so this is x squared times x minus 2 times x plus 2 is equal to 0, and this is a difference of squares. Whoops, don't need to have that. Okay, so we just did a couple of different factoring techniques there. And so now we can use our zero product property. If this times this times this is equal to 0, then 1 or 2 or all 3 of these things must be 0. Okay, so let's take a look. So one of these things says x squared has to be 0, or x minus 2 has to be 0, or x plus 2 has to be 0. Well, this is the square root of both sides, which is plus or minus 0. Well, that's just 0. Add 2 to both sides, x equals 2. Subtract 2 from both sides, x equals negative 2. Okay, so for our fourth degree polynomial, it looks like we have 3 zeros. Okay, and I'll list those in numerical order. The zeros are negative 2, comma 0, comma 2. Okay, and let's take a look at that again with our graph so we can see those. So back to y equals, let's clear out that previous equation. X to the fourth minus 4x squared, and I will graph that. And you can see 1, 2, whoops, there, okay, there we go. Okay, let me zoom in a touch. Let's zoom in. Let's get my window to go from negative 5 to 5. The standard goes from negative 10 to 10. Let's just have this, make it a little bit clearer. Negative 5 to 5, a little bit closer. And there we have it. And so you can see, I won't do the whole calc process, but you can see here it's crossing, has an x-intercept at negative 2, where it crosses the x-axis. It's touching the x-axis, but not crossing at the origin at x equals 0, and then is crossing the x-axis again at positive 2. And again, you can check those with your calc 0 function to see what they are. So there you have it. We have found zeros using factoring.